Hello, this is video 2 for Interim 3, Math 8th grade at Mercer Middle School. So this standard has you make approximations of irrational numbers to compare the size of the irrational numbers, locate them on a number line, and estimate the value. For example, this should say pi squared would mean approximately 3 1400ths squared, which is a little bit more than 9. So it's about 9. So remember, we're doing an approximation using a fraction, not using an exact value. And we're estimating the value of an expression. So it says no calculators allowed. It's because we're using estimation strategies, and also because you need to be able to know how to estimate a square root that is not a whole number by using some strategies we're going to talk about. So first of all, we're going to place these numbers on the number line. The number line we see here goes from 0 to 12, so that tells us none of these should have a value less than 0 or greater than 12. So let's start with some of them that are perfect squares or whole numbers. Square root of 24, nope. Square root of 49, yes. Square root of 49 is 7. That is a whole number. I skipped this one because we're going to find in a minute that's not going to be a whole number. Square root of 7, that's not going to be a whole number. It's not a perfect square. Square root of 4 is, so 6. What is the square root of 4? 2 times 2 is 4, so 6 over 2. And then look at this. 6 over 2 is just a division problem. 6 divided by 2 is 3. But we want to put the original number on the number line, not the simplified version, so we can keep track of where we're placing this. So I'm going to find 3 on this number line. Here it is. I'm going to mark it, and I'm going to put 6 square root of 4. 6 divided by square root of 4. The value of this number is 3, so I can place exactly on 3. I know the value of the square root of 49 is 7, so I'm going to find 7, and I'm going to put square root of 49. I'm already done with 2 out of the 5. Now I'm going to go to the ones that are a little bit harder. Square root of 24. Now I'm not going to be using a calculator because you can't use a calculator, so we're going to be doing some work to estimate this. Square root of 24 is, let's try to do some whole number estimations. I'll start with 3 times 3 is 9. Well, that's too small. 4 times 4 is 16, still too small. 5 times 5 is 25, too big. Now look how close I got. 4 times 4 is 16. So 4 squared is 16. So that's too small. 5 squared is 25. That's too big. So right now, I know that I am looking for a number that is between 4 and 5. So actually I'm going to erase this squared up here. I'm going to erase that squared up here, because the square root of 24 on a number line would be between 4 and 5. So I already know I'm looking somewhere in here. Let's mark that. Somewhere in here is where the square root of 24 goes. Now, notice that 4 squared was 16 and 5 squared is 25. Which one is it closer to? Square root of 24 is really close to the square root of 25. So I could say the square root of 25 is 5. It's going to be really, really close. So I'm going to put it right here. Notice I didn't even find the decimal. I just knew that the square root of 25 was 5. The square root of 16 was 4. So the square root of 24, there's 16, 17, 18, 19, 20, 21, 22, 23, 24, would be really close to 5. So remember, we're just estimating, so I put it really, really close to 5. Let's look at the square root of 7. Same process. 2 squared is 4. Nope. 3 squared is 9. Also no, but now I went too low with 2 and too high with 3. 2 squared was 4. It's too small. 3 squared is 9. That's too big. So I know the square root of 7 is 2 point something. It's between 2 and 3, because the square root of 4 is 2 and the square root of 9 is 3. So square root of 4, square root of 5, square root of 6, square root of 7, square root of 8. It's going to be somewhere around here. So I'm going to find 2 and 3 on my number line, and it's going to be fairly close to 3. I'm estimating. No one would expect you to find an exact decimal on this line. But I know it's more than 2.5 because it's really close to 3, and it's less than 3 because square root of 9 would be too high. So we've got 2 point something, and this was 4 point something. Last one, 3 multiplied by the root of 2. So 1 squared, now remember this is 3 multiplied by, well, 1 squared is 1, so it's too small. And then 3 multiplied by 2 squared is 4, so that's too high. So it's going to be somewhere between 3 multiplied by 1 and 3 multiplied by 2. So that's actually quite a range. That's between 3 and 6, so we got to be a little more careful here. Let's actually get a decimal then for this. So let's try 1.3. 1.3 times 1.3 and see if we get 2. 1.69. 1.3 squared is 1.69. So let's try a number a little higher. We're trying to get to 2. Let's try 1.4 squared. And tenths times tenths is hundredths. Hey, look how close we got. 1 and 96 hundredths. I'm going to call that close enough. 1.3 squared was 1.69, too low. 1.4 squared was 1.96. That is 4 100ths away from 2. That's very close to 2. So let's use 1.4 as an estimation. So 3 multiplied by the square root of 2. 3 multiplied by 1.4. So that's going to get us pretty close, a good estimate of 3 times root 2. So we're going to find 4, and we're going to say it's approximately here. It's a little bit less than 4.5, but bigger than 4. 3 square root of 2. Circle all expressions that have a value greater than 5. We're looking for bigger than 5. So again, this is an estimation standard, which is why we're not using a calculator. But look at this first one. The square root of 9 is 3. So that just says 4 take away 3. Well, you know what 4 take away 3 is. It's 1. Does that expression have a value greater than 5? That value is 1. No, that's not greater than 5, so we're not going to circle A. 2 times pi. Notice I'm doing calculations as well. I'm not just picking one of these values. I'm thinking through each one and choosing them based off the criteria they gave us. 2 times pi. 2 multiplied by approximately 3 and 14 hundredths. Well, 3 and 14 hundredths times 2. You know, I don't even need to do this work. Look, 3 and a little bit more. 2 multiplied by 3 is already 6. More than that, so there's definitely going to be greater than 5. Notice I'm not even going to finish my calculations. I know that 3 times 2 is 6, so 3 times 2 plus a little more is also going to be greater than 5. Last one. 5 and 7/10 take away 6 divided by the square root of 20. Again, got to do some work here to figure out what's going on. Square root of 20 is going to be an irrational number, so 5 and 7/10 take away 6 over. Now square root of 20, let's estimate that. 5 times 5 is 25, that's too big. 4 times 4 is 16, that's too small. So it's going to be 4 point something. 4 point something. Let's find a good estimation for that. So let's do 4.2. 17.64. We need a little bit higher. Let's try 4.4. And that got me pretty close, 13.96. Maybe it's going to be more like 4.5, but let's take a look here. Let's pretend it's about 4.4. Let's estimate it's about 4.4. 6 divided by 4.4. So we're looking for a value greater than 5. So if this was 6 divided by 4, that would be 1 and something. So it would be bigger than 1. 6 divided by 5, even if we overestimate it, 6 divided by 5 is still bigger than 1. This is an improper fraction. That means this value is bigger than 1. So think about it for a second. 5 and something take away more than 1. Well, taking away more than 1 is going to definitely make this 4 point something, at least. So there's no way that's going to be greater than 5. So the kind of thinking you need to do here is not calculation. It's not taking a calculator and finding the exact value. This standard has you estimate, thinking about approximately what something would be, and then reasoning and figuring out, well, adding, taking away, multiplying, approximately what am I going to get? Am I going to get greater than 5? If not, I don't circle it. Reminder that if you're struggling with this standard, please look out for help. Go on to Khan Academy, ask your teacher, morning math, whatever it is you need to do, and add to your toolkit the parts that you are confused about.